The architecture of modern industrial control systems has long been networked. With the enhancement of industrial control system performance, the demand for networking continues to evolve with the demand of interconnection and interoperability of various control systems networks, including controllers, remote I/O, and the increasingly widespread application of field bus. Therefore, establishing communication between different control systems has become a routine requirement in the implementation of automation engineering, and Modbus is one of the most commonly used communication methods. The Modbus protocol uses master-slave communication, where the master device actively queries and operates slave devices. Typical master devices include industrial PCs and controllers, while typical slave devices include PLCs and programmable controllers. The master device sends requests to the slave devices, which analyze and process these requests, then return the results to the master device. Modbus function codes specify the purpose of a Modbus message frame. For example, function code 03 is used to read holding registers, and function code 04 is used to read input registers. When the master device sends a message to the slave device, the function code tells the slave what action to perform, such as reading the status of an input switch or reading data from a group of registers. When the slave device responds, the function code indicates whether the response is normal, no error, or if an error has occurred, called an exception response. In a normal response, the function code sent by the master equals the function code in the slave's response. From the Modbus protocol stack, we can see that the main difference between Modbus TCP and other Modbus protocols lies in the transport layer. Modbus RTU and ASCII rely on serial communication, such as RS-232 and RS-485, while Modbus TCP uses TCP/IP over Ethernet. This adaptability makes it a popular choice for industrial applications. In Modbus TCP, IP addressing replaces the need for slave addresses, and CRC checks are omitted as TCP/IP includes error checking. Additionally, Modbus TCP incorporates an MBAP Modbus application protocol header for transmission over TCP/IP networks. This diagram illustrates the Modbus TCP application architecture. On the left side, we can see PLCs, HMIs, SCADA systems, and network switches, all communicating via Modbus TCP. The Modbus gateway in the middle can convert Modbus RTU protocol to Modbus TCP protocol, enabling them to be managed under Modbus TCP. As Modbus TCP operates over Ethernet, monitoring the status of network switches by Modbus TCP protocol is necessary, requiring the switches to support Modbus TCP protocol. WoMaster Layer 2 and Layer 3 Ethernet switches support Modbus TCP protocol with complete Modbus TCP table and register for monitoring the models and status of the switches. Let's proceed with a demonstration. We'll use a DP412 switch connected to a PC via an Ethernet cable. We'll enable Modbus TCP on the switch and then run Modbus poll on the PC to read the switch's parameters. First, open web browser and enter the IP address of the switch and then log into the switch. Go to the industrial menu to set up Modbus TCP. Here we change the status to enable Modbus TCP and use the default TCP port number 502 or other port number by your network setting. Click Submit to activate the change, and save the setting to memory. After Enable Modbus TCP, we open the software Modbus poll. Go to the connection menu and choose Modbus TCP IP mode. Enter the IP address of the switch and the TCP port number that we just configured, which was 502. Press OK to change. The error of illegal function is showed because we didn't complete the configuration. We go to Setup and Read-Write Definition to configure the Modbus parameter. We specify function code 03 to read the Modbus register and address 0 for the product name. We can receive the register value. To read the value, we can change display to hex number. There are reference table that we can check ASCII code for the hex number. With the help of the ASCII table, we can convert the HEX number to the character. For example, 44 means D and 50 means P. The Modbus Poll software is just a demo to read Modbus. You can use other Modbus software for real applications. Finally, we can convert the HEX to DP412v2, which is the model name of the switch. This concludes the demo of Modbus TCP.